Hi, Dr. Kindness, or I guess anyone that managed to find this on YouTube. I just wanted to do a video demo and walk through the simulation of my final project to show that it works. I'll also post like a transcript, like a paragraph of this on the report form. But I thought it'd be good to have a video too. So this is my simulation. The three inputs that I'm going to control through the sim file are current byte, new byte, and transmission in progress. These are the three outputs from the Raspberry Pi. This is 8 bits, this is 1 bit, this is 1 bit. I have the transmission starting at, I believe, time equals 5 microseconds. And right now what's loaded into the memory is the sample program from Project 5, where it's like the counter that counts every time there's an interrupt. And it's going to get overwritten once the transmission starts with the file from Project 4, the example file where like it outputs the switch, like it takes the input from the switches and outputs it to the LEDs. So that's what's going to happen. You'll see that these memories are going to get overwritten as each new IR instruction comes in. So on the way I have it set up, even though there's only 4 bytes in each IR, you generate and you put an extra byte at the end because the byte collector FSM needs an extra state at the end to output. Otherwise you get like undefined behavior and it acts all weird. So that's how I made it behave. And this models exactly the Python script that I wrote. So let's get started. Nothing's happening, and at 5 microseconds, this transmission in progress signal should go high, and it does. And that's going to make the control FSM go into the hold state. It's going to set memwrite high. It's also going to set some mux selectors, which I don't have up here. Yeah, memwrite goes high. New byte goes high right a little bit after that. And the way the byte collector works, every positive edge of new byte is when it logs, is when the FSM changes. So I have to have on the very first byte that goes through, I have an extra wave pulse, because there's a 0 state, which is the state before any bytes come in. So yeah, you'll see that. So here is the next byte. We have a down. Let's see here. There's a little drop, and then it goes back up. So that's the next positive edge is the next byte. So this right here is now byte 1 of the first IR instruction. Byte 2, byte 3, and then we're going to have byte 4, and it's going to output 1, 2, 3, 4. Oh no, yeah. So on the 5th byte, it's going to go into the output state. It's going to output. Let's see here. The new new IR is going to go high next time. This is just the first. I intentionally made the first instruction no op, which is 13. It's represented by the hex value 13, because it doesn't get outputted for some reason. It misses the first instruction. So yeah, we see the next clock cycle. This goes high. That's the new IR line. Okay. New IR is what gets clock gated into the memory. So the new IR is an output from the byte collector that tells the memory when to write. All right. And yeah. So now so you can see it misses this first instruction because the rising edge is right at the point where it's undefined. so it misses that first one. But you'll see it'll get the next ones, which are meaningful and not just a no-op. So we have byte counts. Let's see. Yeah. So 1, 2, 3, 4, and then on the next one, it's going to output. Okay, yep. We get a new IR signal. And it writes it into the 0th memory slot, which is good. It's what we want. Yeah. Yeah. Memory address. Yep. Okay. We keep going. And as you'll see, the pattern continues. Get more and more bytes, more and more memory addresses getting overwritten. Don't mind the noise in the background, that's just my roommates. Okay. I'll try to keep this video somewhat short. Okay, and now it's fully overwritten, and okay, we just passed the point where, crap, okay. Okay, so right here is where the transmission ends, where the transmission in progress goes low. All right, and let's see what the behavior is at that point. So at that point, the PC out should be 0. Yeah, and it is. And this memd out, memd out 1, this is your IR that's coming from the memory. So that's going to tell us what it is. So we're going to read the first one that we inputted, which is 110002B7, which as you can see is coming from this first memory slot that we overwrote. Program counter is at line 4. And it's going to run through, you can see this memd out, that's our IR that we wrote in here. And it's going to run through that program. And eventually we're going to get to the point where we output 1 to the LEDs, because the switch values are set to 0. And as we remember, the program from Project 4 took the switch input, added 1, displayed it to the LEDs, so that's exactly what it's doing. And it's just going to keep doing this indefinitely. It's basically like the board has been reprogrammed just by doing that. Yep. So there you have it. I'll write up I'll write this up too. So yeah. Thanks for watching.